Okay, so this will be our last topic under chapter 2, the methods of integration, and under the integrals of improper functions. The second one is this one, the rationalizing substitution. So in the last method that we discussed, we discussed the partial fraction. It's a method in which we integrate a rational function. Now, what in this next method, we will be talking about rationalizing substitution. And this means if we have functions that are not rational or irrational functions, then we cannot apply the the method that we discussed before, the uh, integration by partial fraction. So what we do is to do a substitution uh, in z. Let's use z instead of u. Then we convert this one into a rational. We transform that irrational function using some substitution into a rational function. That's why it's called rationalizing substitution. Then after converting this one into a rational function, we can now apply partial fractions. So in order to do this one, let us define what's irrational functions. Irrational functions, these are functions that are not rational or functions that contains radicals mostly. So when you see roots, square roots, and roots of a polynomial, then that is not a rational function. We cannot apply uh, the partial fraction. So we need to convert first that one. So the first case, if the integrand contains this one, the nth root of a polynomial ax plus b, a and b are constant and the root is also a constant, then we use the substitution z raised to n should be equal to ax plus b. We just replaced uh, ax plus b with z raised to n. If it's just or more than 1, if it contains more than one radical, so for example, we have here nth root of x, then you still have mth root of x, and so on. Then what should be our substitution? So what we do is to use the substitution z raised to, let's say, e is equal to ax plus, or just x. If it's just x but it's ax plus b, then you can use ax plus b. But for general, if it's just x, where p should be the least common multiple of uh, n and m, or LCD of 1 over n and 1 over m. So let's take an example to illustrate this case. First example. Oh, this one. This is not a rational function because we have a radical on the numerator. So we need to use a substitution. So what substitution we'll be using should be this one, z raised to n equals ax plus b. Here we have only x, so the substitution should be, our n here will be 2 because it's square root. If it's cube root, then n is equal to 3. So therefore, z squared, z raised to n, should be equal to ax plus b, or just simply x, or x equals z squared. Then from here, square root of x now will be equal to z. And if you want to solve for, next we will be solving for dx, the derivative of x with derivative of z squared. This is 2z dz. And now we convert all the x's into z's to complete our substitution, rationalizing. So let's do that. So we have, at the numerator, we have square root of x, which is equal to z. This is z. Then at the denominator, we have x minus 2. What is our x? Our x is z squared. So this is z squared minus 2. Then multiply it with dx. Our dx is 2z times dz. And just simplify this one. And if you observe, now our integrand is now considered a rational function. 2z squared over z squared minus 2. So this is now rational. We can now apply the methods of partial fractions. But before we do that, we check if this is a proper or improper. The degree is the same, so we can still divide this one. We can divide 2z squared divided with z squared minus 2. So this will be 2. So 2z squared minus 2 times 2, 4. Then subtract. So we have a remainder of 4. So the integrand now will become, this will be the integral of 2, then the remainder plus 4 over z squared minus 2 dz. Then we can now integrate. We distribute the integral, so this will be the integral of 2 dz plus the integral of 4 over z squared minus 2 dz. We can solve the first term. 2 dz is just 2z. The second term, 4 over z squared minus 2. How do we integrate this one? We can use the formulas. We derive the additional standard formulas. The formula is the integral of du over u squared minus a squared. And this is equal to 1 over 2a, 1 over 2a ln of x minus a, or u minus a, all over u plus a plus c. We can use this formula, and what will be our a here, because this is 2, will be square root of 2. A will be equal to square root of 2. So if we integrate now, integral of 2 dz is 2z plus integral of this one, we have 4 dz over z squared minus 2. So z squared, our a is 1 over 2 times the square root of 2. Our a is square root of 2. Then ln of z minus a, which is square root of 2, all over z plus square root of 2. Then plus c. Then, so the integral or the integration is over. We need still to go back to the original, where z is equal to the square root of x. So the integral of square root of x. Now the integral of square root of x over x minus 2 dx is now equal to 2 times z. Our z is here. Z is square root of x. So z, 2 times the square root of x plus this one, 4 divided by 2 is 2. 2 divided by square root of 2. Divided by square root of 2. So 2 over square root of 2. We can 2 over square root of 2 times the square root of 2 square root of 2. And this will be 2 square root of 2 over 2, or simply square root of 2. So plus square root of 2 ln of z is square root of x, square root of x minus square root of 2 all over square root of x plus square root of 2 plus c. So that is rationalizing substitution. We need to choose the proper substitution. Then our goal is to rationalize the problem so that we can apply our methods in the previous discussions. So let's take another example. This one, integral of dx over x raised to 1 half minus x raised to 1 fourth. There's no radicand here. How is this a rational or rational function? This is the same as the integral of dx over the square root of x minus the fourth root of x. So to choose for our substitution, let x be equal to z raised to n. Now, what will be our n here? Our p. We have two radicands, two index, 2 and 4. So what's the LCM? The LCM is simply 4. So therefore, our substitution should be x equals z raised to 4. 2 and 4, what's the LCM of 2 and 4? It's 4. So we use z raised to 4. Then dx will be equal to 4z cubed dz. Then what will be x raised to 1 half or square root of x? X raised to 1 half is z to the 4th raised to 1 half. So 4 over 2, so this will be z squared. And we also have x raised to 1 fourth. So this will be z raised to 4 raised to 1 fourth. And 1 fourth over 4 is 1, so it's just equal to z. And we can now do the substitution. So the integral, the numerator dx, or dx is 4z cubed dz, all over x raised to 1 half, which is z squared, then minus x raised to 1 fourth, which is z. Then this is now our new functions, which is a rational function. Then before we apply partial fraction, we first derive or take the division, because the degree of the numerator is greater than the degree of the denominator. So it's an improper fraction. So we need to divide. So divide 4z cubed with z squared minus z. Then we multiply it with 4 times z, so that it will become 4z cubed. Then you multiply it with z, so minus 4z squared. Then subtract. So this will be negative of negative, so 4z squared. 4z squared. Then we can still divide further. We just need to multiply it by 4. So this will be 4z squared minus 4z. Then subtract again. This will be 0, negative, negative, so positive 4z. So we can now rewrite this one as the integral of 4z plus 4 plus the remainder, which is 4z. And you need to divide this one with the denominator z squared minus z dz. Then we can distribute the integral. So this will be the integral of 4z dz plus the integral of 4 dz plus the integral of 4z over z squared minus z dz. So here we can cancel out the other z at the numerator, the one z here and the other z here. And we can also factor out 4. And this will be z, integral of z dz will be z squared over 2, so 1 half z squared plus integral of dz is this z plus this one. The remaining here will be 1. This will be 1 over z minus 1. And what's the integral of 1 over z minus 1? Let u be equal to z minus 1. So that du is just equal to dz. So it's just du over u. Integral of du over u is just ln. Our u is z minus 1. So ln u is ln of z minus 1. Then that's it, plus c. Then we go back to x. We need to solve for what is z squared. Our z squared is square root of x. Z is fourth root of x. So the integral now of dx over x raised to 1/2 minus x raised to 1/4 is equal to 4 times 1/2. So that's 2 times z squared. Z squared is equal to square root of x. So 2 times square root of x. Then plus 4 times z. Z is fourth root of x. So 4 times the fourth root of x, or x raised to 1/4. Then plus 4 ln of x. Z is fourth root of x minus 1 plus c. And this is now the result of the integration of dx over x raised to 1/2 minus x raised to 1/4. Okay, now let's take more example under this case. Evaluate this one. Example. What if it contains x plus 4 over x dx? What will be our substitution? So it's the same solution. Let z be equal to what? Or x be equal to what? Or z, our n here is 2, so z raised to n. So z squared will be equal to ax plus b, or x plus 4. And from here, we can solve for x. X will be equal to z squared minus 4. Then dx will be equal to derivative of 2z squared is 2z dz. Derivative of negative 4 is 0. Then that is 2z dz. What is the square root of x plus 4? From here, square root of x plus 4 will be equal to z. Square root of z squared. Then we can now do the substitution. So the integral of square root of x plus 4, that is z all over x. Our x is z squared minus 4. Then you multiply it with dx, which is 2z dz. Then simplify this. This will be the integral of 2z times z squared all over z squared minus 4 dz. And this is the same as the previous example. So if we integrate this one, we can divide first 2z squared over z squared minus 4. And that will be 1, 1. Or 2 plus the remainder. So let's just divide this one. So z squared, 2z squared, z squared minus 4. So you multiply it with 2. So 2z squared and minus 8. So the remainder is 8. So this will be the integral of 2 plus the remainder 8 all over z squared minus 4 dz. And it's the same formula that we used before derivative of du over u squared minus a squared? And the answer is, so note, formula du over u squared minus a squared is equal to 1 over 2a ln of u minus a over u plus a plus c. So that will be our formula for the second term. Our u here will be z, our a will be square root of 4, and that's 2. So we'll now is the integral of 2 dz, 2 times dz, this is just 2z, plus the integral of dz over z squared minus 4, so 8. 8 times 1 over 2a, our a is 2, 2 times 2. Then ln of u, z minus 2 over z plus 2. Then plus c. So that's the integral in z. Now we go back to x. We need to determine what is our z. Our z is square root of x plus 4. So we just substitute z with x plus 4. So therefore, the integral of the square root of x plus 4 all over x dx is now equal to 2 times z, or z is x plus 4. So 2 times the square root of x plus 4. Then plus 8 divided by 2 times 2. 2 times 2 is 4. So 8 over 4 is 2. So 2 ln of z minus 2, this is x plus 4 minus 2 all over z, x plus 4 plus 2 plus c. And this is now the integral of square root of x plus 4 over x. Then next case. So the first case is when the radicand contains linear functions inside the radicand. So what happens if we have a quadratic? So if we have a binomial quadratic function, so for example, x squared minus a squared, or x squared plus a squared, or a squared minus x squared. So if the radicand of the integrand contains this form, all this form, these basic three forms will involve trigonometric substitution. So we just use trigonometric substitutions. Just substitutions. That will be case 2. We already discussed trig-sub, so you know how to do that. Then what if it still contains a quadratic expression, but it's not in the form of this 3 in case 2? So in the form integral x squared plus ex plus let's just say q, in this form x squared plus px plus q, where p and q are constant. Then the substitution that we will be using, and remember, this is not factorable, irreducible, so we use this substitution, x squared plus px plus q be equal to z minus x squared. So this will be our substitution. Now let's take an example to illustrate this one. Integral of dx over x times the square root of x squared plus x plus 2. So the integrand or the radicand contains a quadratic expression that is not in the form of case 2. So this is under case 3. What will be our substitution? So x squared plus x plus 2 will be equal to z minus x squared. Z minus x squared. So then, if we solve for x, we need to solve for x from here. First, we need to expand this one. So this will be z squared minus 2 times zx plus x squared. And at the left side, x squared plus x plus 2. We can cancel out x squared and x squared. Remember, we need to solve for x. So this will be x plus 2 equals z squared minus 2zx. And I'll put this one at the right, the left side. So that this will be x plus 2zx. Then I'll put 2 at the other side. So this will be z squared minus 2. Then I factor out x at the left side. So this will be 1 plus 2z equals z squared minus 2. And I need to solve for x. So divide both sides by 1 plus 2z. So x now will be equal to z squared minus 2 all over that 1 plus 2z. So that will be our x. Then the next step is to solve for dx. So we need to take the derivative of that. So dx will be equal to, so how do we take the derivative? This is a quotient. So we apply quotient rule. Low the high times high the low over low squared. So this will be 1 plus 2z. This is squared. Then low the high. So this will be 1 plus 2z low. Lower function times the derivative of the numerator, which is equal to z, the derivative of z squared minus 2 is just 2z dz. Then minus I, z squared minus 2 times the derivative of the denominator 1 plus 2z, that's just 2dz. Then simplify, so we can factor out dz. So here we can distribute that 2z. 2z plus 2z times 2z plus 4 z squared, then minus 2 times z, so 2z squared minus minus a negative plus 2 times 2, so 4. Then I factor out dz all over 1 plus 2z squared. We can still simplify this further. For 4z minus 2z is 2z squared. And we have 2z, then we have 4. We can factor out 2. Factor out that 2, so we have 4z minus 2z squared. So 2 times z squared, then plus 2z or plus z, then plus 4, we bring out 2, so we have just 2 dz all over 1 plus 2z squared. So that will be our dx. Then we need to solve for the square root of x squared plus x plus 2. And from here, we can do that. So if we take the square root of x squared, square root of x squared plus x plus 2, that will be equal to z minus x, or the square root of z minus x squared. But we have x here. So we need to substitute the x that we already solved here. It's z squared minus 2 over 1 plus 2z. So minus z squared minus 2 all over 1 plus 2z. 1 plus 2z. Then you can simplify that. LCD will be 1 plus 2z. Then 1 plus 2z times z. So we have what? Z squared. Z times 2z. So we have 2z squared. Z times 1. So plus z minus z squared minus minus so plus 2. Then 2z squared minus z squared is just equal to z. So therefore, the square root of x squared plus x plus 2 will be just equal to z squared plus z plus 2 all over 1 plus 2 times z. Then we can now do the substitution. We already have the square root of x squared plus x plus 2. We have dx, and we already have the value for x. So we can now do the substitution. So the integral of the numerator dx. So what is our dx? Our dx is this one. So this is 2z squared plus z plus 2 all over 1 plus 2z squared. That is dx. Then all over here we have x. So our x is this one, z squared minus 2. Z squared minus 2 all over 1 plus 2z. Then we need to multiply this one with the square root of x squared plus x plus 2, which is already this one, so z squared plus z plus 2 all over 1 plus 2z. Then before we integrate, we need to simplify the function. So we need to multiply the denominator. 1 plus 2z times 1 plus 2z. Then we can cancel out the 1 plus 2z squared at the numerator with that in the denominator. So this will cancel out. One plus 2z squared, and this one 1 plus 2z times 1 plus 2z. Then we can also cancel out z squared plus z plus 2 and z squared plus z plus 2 at the denominator. So the remaining will be 2 dz all over z squared minus 2. Then how do we integrate this one, z squared minus 2? We already done this one. Again, it's the same formula that we used in the previous examples. Note the integral of du over u squared minus a squared is equal to 1 over 2a ln of u minus a over u plus a as c. Our a here again is square root of 2. Our u is z. So we will be having that 2. Then you divide it with 1 over 2 square a. A is square root of 2, so this is 2 times square root of 2. Then ln of u, our u is z minus a square root of 2. Then we have z plus the square root of 2 plus c. And we can cancel out this 1, 2, and 2. So we have 1 over the square root of 2, or square root of 2 over 2. Then we can now substitute the value for z. Our z is equal to what? Our z is this one. We can solve z from here. So from here, z is equal to the square root of x squared plus x plus 2, then you just need to subtract it with x. So the final answer now will be the integral of dx over x times the square root of x squared plus x plus 2 is equal to 1 over square root of 2 or square root of 2 over 2 ln of z, which is the square root of x squared plus x plus 2, then we need to subtract it with x, then minus square root of 2 all over x squared plus x plus 2, still minus x, then this time it's plus square root of 2 plus c. And this is now our final answer. For the integral of dx over the square root of x times the square root of x squared plus x plus 2. Now for the last case, if the integrand contains this form, case 4, q plus px minus x squared. So if the integrand contains this one, then we will be using the substitution, which is we can write this one as alpha plus x times beta minus x, where alpha and beta, it's the factor. They were the factor here. Then the substitution will be q plus px minus x squared equals alpha plus x squared z squared. Or we can use the other factor, q plus px minus x squared is equal to beta minus x squared times z squared. It's another substitution that is useful if you encounter this type of problems. For example, the integral of x dx all over 5 minus 4x minus x squared raised to 3 over 2, or that's the square root of the cube. So solution, so this is case 4. What will be our substitution? First, we need to factor that out. 5 minus 4x minus x squared. This is the same as x 5 and 1. If you add them, it's equal to negative 4. So 5 and 1, then it should be minus x plus x. 5 plus x, 1 minus x. So we can use this one, the substitution that we'll be using can be, this will be equal to, we can use 1 minus x. 1 minus x, your beta is equal to 1, then you multiply it. You square it, then you multiply it with z squared. And this will be 5 minus 4x minus x squared. That will be the substitution, and from that we solve for x. 5 minus 4x minus x squared equals 1 minus x squared z squared. Then solve for x. So this is 1 minus 2 times 1 times x, so 2x plus x squared, and you multiply it with z squared. Then we solve for x. We can make this one as 5 plus x by 1 minus x. so that we can cancel out that 1 minus x at the right side. So 1 minus x square z squared. So we can cancel out this one and the other one. Then the remaining will be 5 plus x equals, you can distribute that z squared minus z squared times x. Then x, the z squared will become positive. Here z squared x. Then I'll put the 5 at the other side, so this will be z squared minus 5. Then I can factor out x. X will be 1 plus z squared is equal to z squared minus 5. Then solving for x now will be equal to z squared minus 5 all over 1 plus z squared. Then the next step is to solve for dx. Again, dx will be equal to the high quotient rule, so this will be 1 plus z squared low 1 plus z squared multiplied by the derivative of the numerator, z squared minus 5, and that will be 2z dz. Then minus the numerator, z squared minus 5 multiplied by the derivative of the denominator, 1 plus z squared. Again, that is 2z dz. Then simplify, factor out dz dx will be equal to 1, this one, 2z plus 2z cubed minus z squared times 2z cubed plus minus 5 times 2, 10z. So 10z multiplied by dz all over 1 plus z squared. Then we can cancel out 2z cubed. Then we can add that one, 2z plus 10z is 12z. So dx now will be equal to 10 plus 2, it's 12z dz all over 1 plus z squared. Then next is to solve for the square root of 5 minus 4x minus x squared. Although it's not square root, it's 3/2. But we just need to solve for the square root. Then we just need to cube that one later on. And this will be equal to 1 minus x times z, because 5 minus 4 minus x squared is 1 minus x squared and z squared times z squared. So if we take the square root, we only have 1 minus x times z. But there's x in this substitution, so we need to substitute the x that we already solved. This is z squared minus 5 over 1 plus z squared. So this will be 1 minus z squared minus 5 all over 1 plus z squared. That is x. And times z. Then we can simplify further. This will be 1 plus z squared, then 1 plus z squared minus z squared plus 5 times z. So this will cancel out. So we have 1 plus 5 is 6 times z, so this will be 6z over 1 plus z squared. And we can now make the substitution to the problem x dx over 5 minus 4 x squared, or this is the same as the integral of x dx all over the square root of 5 minus 4x minus x squared. Then you just cube this one. So let's do the substitution. So the integral of the numerator contains x. So we have x equals z squared minus 5, z squared minus 5 all over 1 plus z squared. And then you multiply it with dx. Our dx is 12z dz all over 1 plus z squared. Then you square it. So this is x times dx. Then at the denominator, we have x again, or no, it's the square root of 5 minus 4x, which is 6z over 1 plus z squared. This is the square root, but we need to cube this one because it's raised to 3 halves. Then that is our new function, rational function. And we can simplify first this one before we integrate. So how can we simplify? This is cube. So there are 3, so we can cancel out this, and this. It's cube. Then 6z cube. Then at the numerator we have z squared minus 5 times 12z. We can also cancel out the z here and the other z here, it's squared, and this will be 12 times the integral of 12 times z squared minus 5 times dz all over 6 cube, or that is 216 z squared. Then 12 divided by 216 will be equal to 1 over 18. 1 over 18, the integral of z squared minus 5 all over z squared dz. Then we can divide this one. We can just, z squared divided by z squared is 1 minus 5 over z squared. So this will be equals 1 over 18, the integral of 1, then minus 5 over z squared dz. And we can now integrate. So here, the integral of 1 over 18 times 1, so that's just z. Integral of dz is just z. So 1 over 18 z, then minus integral of 5 over z squared. So you can put z squared at the numerator, z squared, then you add 1. So negative 2 plus 1 will be equal to a negative 1. Then you multiply it with negative 1, so this will be positive. Negative. Then 5 over z, or 5 times z raised to 1. Z raised to negative 1. Or you bring down that negative to become positive. And you add z. Then we can now do the substitution to go back to x. We need to know what is our z. Our z is, again, this is, where do we get z? You can get it from here. So z from here will be equal to this one here. Z from here will be z equals square root of 5 minus 4x minus x squared all over 1 minus x. So this will be 1 over 18 times that z square root of 5 minus 4x minus x squared all over 1 minus x. 1 minus x, correct. Then plus 1 over z, you just inverse that one. So it will become plus 5 times 1 minus x all over the square root of 5 minus 4x minus x squared. Then plus c. Or before we do the substitution, it's easier if we first simplify in terms of z first. So we can still add this one z times z squared plus 5. So that our substitution will be simpler. And this will be 1 over 18 times z squared. So z squared, you square that one. So 5 minus 4x minus x squared all over 1 minus x, you square it. And plus 5 all over z, or z is the square root of 5 minus 4x minus x squared all over 1 minus x plus c. Then simplify further. We can simplify this further by adding the numerator. So 1 over 18, then numerator 1 minus x squared. Then we have 5 minus 4x minus x squared. Then plus 5 times 1 minus x squared. So 5 times 1 minus x squared all over the square root of 5 minus 4x minus x squared all over 1 minus x plus c. Then we can cancel out 1 minus x. Now there's a problem, 1 minus x squared in the numerator and the denominator will not cancel out. For this to cancel out, let's try another value for z squared. We can use the other for z squared other substitution. So let's do this one. Z, we can use that still z. At the z squared, there's another simple substitution for that. If you go back to here, z squared, or z squared. This one, z squared is equal to 5 plus x over 1 minus x. We can use that one, z squared. Z squared is equal to 5 plus x over 1 minus x. It came from this one, from here. So z squared, 5 plus x equals z squared minus z squared. You factor out z squared, 1 minus x, you divide both sides by 1 minus x. So z squared equals 5 plus x over 1 minus x. We can use that one instead of the first one. So this will be, and z is still the same. Z is equal to the square root of 5 minus 4x minus x squared all over 1 minus x, so that we can cancel out that 1 minus x at the denominator. Then let's do the substitution. 1 over 18 z squared, 5 plus x over 1 minus x, then plus 5 all over z, which is the square root of 5 minus 4 x minus x squared all over 1 minus x plus c. Then we can simplify further the numerator, common 1 minus x, then 5 plus x, then plus 1 times 5, so 5, and negative x times 5, so minus 5x. And then just copy the denominator, 5 minus 4x minus x squared all over 1 minus x, so that we can cancel out now that 1 minus x. Then that will be the remaining at the numerator, 5 plus 5, 10, then 5x minus negative 5x plus x is negative 4x, so this will be 1 over 18 times 10 minus 4x all over the square root of 5 minus 4x minus x squared plus c. Then we can factor out 2 at the numerator to cancel the 18 here. We can write this one as our final answer. So the integral of x dx all over 5 minus 4x minus x squared raised to 3 halves is now equal to 10 over 18. That's 5 minus 2x all over 9. We factor out that 2, we divide it with 18, so it should be 9. That's the square root of 5 minus 4x minus x squared plus c. And this will be our final answer. Okay, so that is rationalizing substitution.